Hey everybody, we're going to continue with our unit on minerals. So last class we learned what a mineral is and what it is not. And today we're going to learn how we can identify a mineral. This is the portion of the year or the unit that is very hands-on, and we usually have a lot of labs. I'm going to try my best to introduce minerals in a virtual way without a laboratory setting. So I'm going to present this slideshow. So how would you identify a mineral if you discovered one on a hike, let's say? What you would need to do is observe the mineral's physical and chemical properties. So identify minerals. Each mineral has its own specific properties that can be used to identify it. The properties that stand out are 1, color, 2, streak, 3, hardness, 4 is how it breaks. It either breaks by what's called cleavage or it breaks by fracture. 5, luster. 6, crystal shape. 7, density or specific gravity. They're pretty much the same thing. Specific gravity is a ratio of an object's density over a density of a known solution or substance. So basically, specific gravity is just like density without units. And then special properties. And we're going to talk about each of these separately, except for crystal shape and density. Since we've spent a lot of time learning about density, you should all have a great understanding by now that every material could have its own unique density. And if it's less dense than 1, it will float. And if it's denser than 1, it will sink. Okay? And crystal shape, that's determined by that internal crystal structure. And a lot of times minerals are broken already, or they don't grow into this characteristic geometric shape. So crystal shape isn't always that good to use when identifying a mineral. So first one we're going to start with is color. So here's a bunch of quartz minerals. Quartz is the most common mineral on the continent. Quartz and feldspar. So what color is quartz? Is it gray? Is it clear? Is it brown? Is it pink? Is it green? Is it purple? Is it red? Well, it's actually all of them. All right. So quartz comes in numerous varieties. If it's yellow to orange, it's called citrine. If it's pink to purple, it's called amethyst. And that's February's birthstone. And if it's a pale pink, it's known as rose quartz. So these are all quartz. So why is color not a reliable property to use when identifying a mineral? Can you say what color quartz is? No. So color is the worst property to use if you're trying to identify something. And the reason behind that is because one mineral could come in a variety of colors. Even a diamond. There's blue diamonds, there's pink diamonds, there's black diamonds, and there's clear diamonds. So that's the answer, because one mineral could come in a variety of colors. And here's another great example. Emerald and aquamarine, 2 precious gemstones. However, even though in jewelry we classify them as 2 separate stones, in geology, they're actually the same exact mineral. The mineral is called beryl. And if it's green variety of beryl, it's called emerald. And if it's the blue variety, it's called aquamarine. But everything else about the 2 minerals, it's a one mineral, everything else about the 2 gemstones is exactly the same. Okay, the only thing different about them is their color. So you never want to go by color. Another 2 popular gemstones is ruby and sapphire. Sapphire can come in any color of the rainbow. It's most valuable when it's blue, a deep blue sapphire. You can have white sapphire and black sapphire. There's only one color of sapphire that you can't have, and that's a red sapphire. If it's a red sapphire, it's even more precious, and we call it a ruby. But when these were first discovered, scientists or gemologists didn't know this. So for a long time, people thought they were totally different gems. In the jewelry world, they still are, but in the scientific studies, we've discovered that they're exactly the same. They're both a greater mineral known as corundum. All right. Now, which mineral is gold? The one on the left or the one on the right? So gold is a color. So they both look gold. So how would you be able to know which one is gold? You perform what's called a streak test. If you ever wrote on the sidewalk with a pebble, then you performed a streak test. Writing with chalk is performing a streak test. So anytime you take a rock and you drag it across the surface and you get a powder or a residue left behind, that is the rock leaving its streak. And sometimes the color of the streak doesn't match the color of the mineral. And the color of the streak is actually the true or real color of the mineral. What I mean is, let me go back actually. So ruby is red and sapphire is blue. Sounds like I'm about to do a poem. However, if I grind them into a powder, or I try to write with a ruby or write with a sapphire on a very hard surface, they both leave a clear to white streak, which is kind of amazing. So the powdered form is identical. They're both clear to white. They don't look anything like the surface. All right. Same thing with a diamond. If I had a blue diamond and I made a streak with a blue diamond, that streak would be clear. It wouldn't be blue. So the streak is actually more reliable than color. So you want to perform a streak test. And we're going to see one in a minute. So the streak is the color of the mineral when it's made into a powder. It's the true color of a mineral. So pyrite, which is fool's gold, is very similar in color to real gold, but pyrite has a green-black streak and gold has a gold or bronze-yellow streak, if you wanted to define gold. Let's watch this clip.
I'm going to take the mineral in one hand, place the streak plate down on the table.
So the streak plate is the white porcelain tile. Okay, your streak plate has to be harder than your mineral. Okay, so we're going to learn that a diamond is the hardest mineral in the world. So if you wanted to make a streak with a diamond, you can only do that with a diamond streak plate. So you would have to basically rub two diamonds together to see the streak of a diamond. Because if you try to make a streak on the white porcelain tile with a diamond, you'll just scratch up the tile. So your streak plate must be harder than the mineral you use.
Press down pretty firmly on the streak plate and drag the mineral across in one line.
Okay.
Do not go back and forth. You're not trying to color.
So you see, that was a gold mineral, but is that a gold streak? No, it's kind of a gray or black. The definition is greenish black, is what it will leave. So the streak actually doesn't match the color of the mineral.
Plate. You can see that this goldish mineral has left a blackish streak on the plate. That would be the mineral's true color in powdered form.
Okay, so why is streak more reliable than color? All right, so even though a mineral could come in a variety of colors, like all those different colors of quartz I showed earlier in the slideshow, would all have an identical streak. So because a mineral could come in a variety of colors, but it can only have one streak. So streak is a much better property to use when identifying a mineral. Okay, next is hardness. Mineral's hardness is the mineral's resistance to getting scratched. And how is a mineral's hardness determined? It's determined by what's called a scratch test. And you use some common household objects. So what you do is you want to see if one object will scratch another. If the material is softer, then that mineral will get scratched. And if the mineral is harder, then the mineral doesn't get scratched, or the mineral will therefore leave a scratch on the other object. So the harder mineral does the scratching, and the softer mineral gets scratched. What a lot of people misinterpret with hardness is they think if something is hard, it can't get broken. And that's not true. People think like, oh, diamonds are hardest mineral in the world. It can't break. No. If you drop a diamond, it could shatter. It, however, won't get scratched. If you put enough pressure on anything, it could break. Another example, glass. Glass is definitely harder than my finger, right? My hand's covered with skin. But if I punch the glass, what's going to happen to the glass? It's going to break. But where my skin hit the glass, that part of the glass is not going to get scratched. And that's actually what we mean in this unit about hardness. Its ability to withstand getting scratched, not breaking. All right? And hardness is measured with a scale of 1 to 10, with 1 being the softest and 10 being the hardest. And the softest minerals in the world are talc, like talcum powder, and graphite. And graphite you all have in your pencils. We call it pencil lead, but they don't use lead in pencils for quite some time. They use graphite. And the hardest mineral is a diamond. A diamond is the only one that's a 10. Okay. So this is called the Mohs scale of hardness. So Mohs is his last name. He was a mineralogist, and he came up with a useful scale to use for a miner, like someone who's looking for precious stones, if they're in the field, something that they would have, things that they would have on them. So, you may have plastic on you, salt. Obviously, you have your fingernail. You might have gold, since that's currency in a lot of places. Definitely, a couple hundred years ago, you might have a block of gold or gold coins, a copper coin. Okay. Window glass. I actually think this copper coin's in the wrong place. I don't think it's a 5. And a knife, okay? Like a pocket knife. So talc and then he gave 10 well-known minerals, and he gave them relative hardness from 1 to 10. And those are the minerals he chose, okay? This is showing a scratch test.
A mineral's hardness is its resistance to being scratched. We can easily test a mineral's hardness against a glass plate. A glass plate has a hardness of approximately 5.5 on Mohs scale, and if the mineral will scratch the glass, it is harder than the glass. If the mineral does not scratch glass or just leaves a powder behind, then it is not as hard as the glass. When testing the hardness, please be careful. Place the glass plate firmly on the table. Hold it down with a couple of fingers on one hand. Take the mineral sample in your other hand. Press down pretty firmly against the glass and make a short scratch in the glass. Try to rub that scratch away. If the scratch remains, that mineral is harder than the glass.
So the mineral he just used has to be harder than a 5.5 because he said that the window glass is a 5.5. So it could be a 5.5. Well, obviously it's not a diamond, so we can pretty confidently say it's not a 10. So all we can say is it's a 5.5 through a 9. All right, but there'll be other things to then test after the window glass to limit your range of hardness.
We'll do this again with another sample. Press down firm. Don't worry about hurting the mineral or the glass. Press down pretty firm and make a short stroke along the glass plate.
So you see how you have a powder or residue left behind? Be careful. So usually this is something that happens normally when we do these labs. You might mistake that for a scratch. Make sure you wipe away that powder and see if there's a real scratch in the glass left behind.
Again, I'm going to try and wipe away that scratch. Notice that the powder that was there before is now gone. That is not a scratch in the glass. So this sample is not as hard as glass.
Okay, so that's how you perform the scratch test using glass, and you can use that with a penny or anything else you want. You could see if the glass, you could do it the opposite way. You could pick up the glass and see if the glass actually scratches the mineral if you weren't sure what was scratching what. All right, so now we're going to go over how minerals break. So since minerals are highly organized with that crystal structure, sometimes they break along specific planes or surfaces. So there's two major ways it could break. It could cleave or it can fracture. So cleavage and fracture describes the two major ways a mineral can break. Cleavage, a mineral will break along smooth sides. And fracture, a mineral breaks with rough or uneven surfaces. So glass would fracture.
It is a breaking process. It's not something that's done very gently.
So this, he's going to put a hammer to calcite. Calcite always looks like a rhombus or parallelogram. So this little mineral right here is calcite. Okay, it's one that we spend a lot of time studying because it exhibits three perfect planes of cleavage. So when you break it, it will break a nice flat surfaces, but along three planes. So it really shows this mineral property really well. All right, calcite's also special. We're going to learn about later because it reacts with acid.
Here is a sample of calcite, and I'm just going to tap it lightly with this hammer and see how it breaks. And here we have it. Here are the pieces that broke off.
So see, you got like lots of little baby rhombuses. I don't know if that's correct. Rhombi. All right, so you had one big piece of calcite or bigger piece, and now you have three like identical pieces. It's kind of amazing. They're all like mini versions of the bigger self.
They still have smooth, flat surfaces. They were not cut. It was not done in any gentle way. So that would be an example of cleavage.
Okay, the next one's going to be fracture. So fracture, a mineral breaks along rough surfaces. So after you break it, it's not going to look like the rock that it just came from. Okay, it's going to look random or oddly shaped. So here, this is a piece of sulfur. It went pretty fast. But let's kind of play that again if I can. All right, so he's going to take a yellow piece of sulfur. Okay, he's going to chip it. So you could tell already this is a broken piece to begin with. You could see that each side is kind of rough or jagged. It doesn't have like these flat surfaces where it might have broken. And he's going to break it, and you get two new pieces that could have broken any random direction. So this is called fracture. All right, luster describes how a mineral reflects light. And there's really only two kinds. There's more than two, but two major ones that we classify in middle school science. Okay, and that is either metallic, pretty simple, does it look like a metal, or it doesn't. If it looks like a metal, you say metallic. And if it doesn't look like a metal, then you say non-metallic.
When identifying a mineral, one of the properties that is most easily seen is luster. Luster is the way in which a mineral reflects light. We're going to break this down into two separate categories: metallic luster and non-metallic luster. If a mineral has a metallic luster, that means it looks like a piece of metal. Not only is it shiny, but it has a silvery or a gold appearance to it. Not all minerals that reflect light and are shiny are metallic. For instance, this mineral easily reflects light, but it does not look like a metal as it is clear. These four samples would be considered non-metallic.
All right. All right. And then you have special properties. So some minerals exhibit some special qualities that make them really stand out and make them easily identifiable almost immediately. And one is called fluorescence. So some minerals will glow under ultraviolet light. So like your teeth have fluorescence because you brush with fluoride. All right, and fluoride makes up the structure of your teeth. So if you were, let's say, at a party and there was a black light, or maybe you have a black light in your room, well, black light's UV light, your teeth might start glowing. You might have noticed this before. If they're not, you need the brush. All right. Another special property is magnetism. So some metallic minerals are naturally magnetic, like magnetite. Okay, and that's named exactly from a magnet, so it's really easy to get right. Magnetite is magnetic. What's confusing is magnesium. Okay, so a lot of kids, last year when you learned about magnesium, you may have wanted to say magnesium is magnetic. No, it is not. Okay, magnesium has nothing to do with magnets. It's just some weird coincidence. All right, and then effervescence. Effervescence is the ability to react or bubble in contact with acid. So some minerals such as calcite will fizz when acid's placed on it. And then you have other minerals that have electrical properties. So a few minerals such as quartz, if you press down on it, if you add pressure, the interactions of the bonds can actually produce an electrical current, which makes quartz very useful for batteries as well as watch faces. So you don't see kids wearing watches as much anymore, but when I was growing up, like you used to see a watch and on the face of that digital watch, it would say quartz. It wasn't the brand. They were just telling you what the face was made out of because quartz can hold a charge really well. And that's why quartz is also used in semiconductors. Okay, so here's some fluorescence. So you're going to see a video right now. It's very short of these minerals under normal light and then under UV light, which is a black light. You'll see how they glow. Oh, let me go back. Okay.
What the minerals look like when exposed to the ultraviolet light.
Right here. Oh my gosh. I don't know why it's doing that. I'm not going to click anything.
What the minerals look like when exposed to the ultraviolet light. Watch what happens when I turn down the white light.
So he's turning off the regular light and putting the black light on. Look at that. It's pretty cool. So you need a black light to show fluorescence. All right, here's magnetite.
But the number one property of magnetite is that it's magnetic. Stick the magnet on there, it's magnetite. So this is the easiest one to find. You just run your magnet over everything in the kit, and the one that it sticks to is magnet.
Okay, so usually in lab, you will have this mineral, and I would give you like paper clips, and it'll be the one that can hold the paper clips. Or I would give you a compass, and it will be the one that will move the compass needle. So here's the calcite fizzing with acid. Call it effervescence. That's an acid dropper. And you see the reaction. So there's only two minerals, common minerals that will do this, calcite and dolomite. But dolomite has to be made into a powder. Okay, and calcite is what shellfish make their skeletons from. So if you found a clamshell at the beach and you actually put acid on it, it will bubble just like that demonstration. All right, that's it for the lesson. Okay, look back, replay things if you need to. If you have questions, feel free to email me. All right, or ask me in the Google Meets. Have a great day, night, or whatever time you're watching this video.